All right, let's move on to the next part of that problem with the derivatives. So this one has two main solutions that are possible. One is through a quotient rule, another one is through a slight trick that you could do. So I want to show you that trick because it makes it much easier in my opinion. But firstly, let me just copy the expression. So we have f of x equals x squared minus 3. And now, you know how whenever we're calculating derivatives, it's actually very inconvenient to have radicals or roots. And that's why we typically prefer to rewrite them as exponents, like x to some power. So how do we do this? You take the number that's inside of the radical, for example 3, and that's going to be the numerator of your exponent. And then the number of the root itself is your denominator, okay? So here, similarly, I would have x. I take the power inside of the radical, which is 2. That's going to be my numerator. And then whatever the number of the root is my denominator. And that's a much better and useful way to use this, particularly when calculating derivatives, okay? All right, so I'll just directly rewrite them in my expression. So that's going to be 3x to the power of 3/4 plus 2x cubed minus x to the minus first. And then we keep going. In the denominator, we have x to the power of 2/3. Now, the trick that I'm going to show you is only applicable if you have one, what is it called, member in the denominator. Even if it was some sort of a product, that's fine. But it wouldn't work if you had plus minus something else, okay? Then you cannot apply this trick. But whenever you only have one thing in the denominator, instead of applying the quotient rule, because it's kind of bothersome, isn't it? There's too much to it. What you can do is you can actually split this one fraction into 4 separate fractions. So firstly, you take the first member at the top, you divide it by the denominator. Then I can actually, wait, there was this thing, okay, the laser. Then you take the second member, you divide by the denominator. Third member divide, fourth member divide. Okay, so these are going to be 4 separate derivatives, and it's actually much easier to calculate, or at least more straightforward than with the quotient rule. So again, I take the first thing, x squared, and I directly divide by x to the 2/3. Or actually, you know what? I'm not going to write this as one expression. I'm directly going to start calculating the derivative, okay? So it's going to be the derivative of this first thing plus, or in this case, it's going to be actually a minus because you have minus here, 3 times the derivative of this quotient. So that's going to be x to the power of 3/4 over x to the power of 2/3. Okay, and we take the derivative. You know how whenever you have constants, you don't have to push them inside of the derivative. They don't change. Okay, so we have plus 2 times, and now you have this combo, x cubed over x to the 2/3 derivative, minus, and now I have this last combo, which is x to the minus first over x to the power of 2/3 derivative, okay? And now you're probably like, well, isn't that 4 quotient rules? But no, the answer is not, because before applying the derivative, you could actually turn this into just one, it's not a number, but just one member without the quotient. How do you do this? Well, you know how to divide variables, right? So when you have division, you just take the first exponent and you subtract from it the second exponent, in this case, 2/3, okay? Minus 2/3. And I still need to take the derivative of this thing. Minus 3 times, and now I have x to the power of 3/4 minus, the minus should be here, 2/3. That's how we divide, okay? And then derivative. Plus 2 times x to the power of 3 minus 2/3 derivative, minus x to the power of minus 1 minus 2/3 derivative, okay? That's getting better. Now we need to calculate the exponents. I will assume that you know how to, subtract fractions from whole numbers and so on. So that's going to be, well, actually, write it in a little bit more detail. So you know how whenever you have this, in order to do the subtraction, you need to represent the integer in terms of something over 3. You just need to have the same denominator in order to perform the subtraction. So 2 can be represented as 6 over 3, right? And then we subtract 2/3. Okay. Here, the common denominator is 12. So I'll expand this by 3 and this one by 4. So it's going to be x to the power of 9/12 minus 8/12. We keep going, so the derivative here, plus 2 times x to the power of. Now, this I need to represent as something over 3 in order for them to have the same denominator. So 3 is equal to 9 over 3. 9 over 3 minus 2 over 3, derivative, and then minus x to the power of minus, this is going to be 3/3 minus 2/3. Again, same denominator. Okay? I'm not explaining this in great detail, once again, because this is not calculus, and I prefer focusing on the calc part specifically. So from here, we just have more calculations to do. So for the first one, we'll have 6 minus 2 is 4 over 3. Minus 3 times x to the power of 1 over 12, derivative, plus 2 times x to the power of 7 over 3, derivative, minus x to the power of, and here you need to be careful, you have minus 3 minus 2, which is minus 5 over 3, okay? Derivative. And now it's finally time to calculate the derivatives. So for each of them, it's the same algorithm. You pull the exponent down first. In this case, it's 4/3. Then you write the x. But now the new exponent is going to be the old one minus 1. So 4/3 minus 1 is 4/3 minus 3/3, which is 1/3. Minus 3 times, bring this down. So that's going to be 1/12 times x to the power of. And now I have 1/12 minus 1, which is 1/12 minus 12/12, which is minus 11/12. This is so hard to pronounce, wow. Plus 2 times, bring this down, 7/3 times x to the power of this thing, minus 1. So 7/3 minus 3/3 is 4/3. Minus, and now because I bring this down and I multiply by it, I have minus times minus, which will give me a plus, right? So I'm directly going to write a plus 5/3 x to the power of minus 5/3 minus 1, which is minus 5/3 minus 3/3, which is minus 8/3. Okay, good stuff. So now we have 1 and 4 here. We can cancel out. The rest of it we cannot cancel out. So we just finalize our answer, and that's it. You see, it still has some calculations, but it would have been much harder if we had used the quotient rule. So that's going to be 4/3 x to the 1/3 minus 1/4 x to the minus 11/12. Of course, you could bring this down to the denominator with the opposite exponent sign, but you're not required to, so you can just stick with that. Plus 14 over 3 x to the 4/3 plus 5 over 3 x to the minus 8/3. And that's your final answer for this problem.